And then we have the sun diagram analysis. And again, these are analysis, not a, a tool, line sights, etc. And definitely the form will change. I'm not sure how the sun and wind were used. He was able to identify the particular location in Mars. He calls it Candor Chasma. It's not clear, or didn't show how it's going to be located or what's the basis of the location. He used aspect ratio as a parameter or as a tool to define the proportion and the scale of the cubes that he will use for form finding. The students had the option to use their original form from the models that they built. The sake of the hypothetical section, this actually can qualify. Then we see the process diagram showing the sun and wind carving, and it's actually correct. And you're wondering why she's starting with a plain cube. This is one of the clearest sun diagram carving submitted this week. You can see the chronological order of how it started and how it ended up. You can see that the folding is actually happening inside, and from this diagram you can see ramps going in and out, forming the hypothetical section. And the hypothetical section is very simple, but it's very clear, and I think it's an important aspect that we need to remember as architects, to be very clear with our communication. You remember this in my thumbnail in my previous video. He segmented the complex form so that he can better understand it. Then on the second slide, you can see that he sectioned it so that somehow we can have an introduction of the different levels. He provided an introduction sheet for his sun diagram carving, wherein he set it at 3 times. Same thing can be said for his wind diagram or the wind carving tool, wherein he indicated the areas for the openings to welcome the air and then the outlet for it. And when it comes to the view carving diagram, I'm not so sure if it is actually good, because it's not about stifling creativity, but it's all about creating parameters for the design. Again, this is not an artwork. This is not an expression. You need to balance the two, because as an architect, we are working with rules and conditions. It's either you create it or you work around it. And for the first 2 episodes, wherein the concept had to be reviewed if it's reflected objectively or physically. Now we are referring to research, how the research is applied towards the orientation of the site, how it affects the form. This is one way to show that architecture is actually a multifaceted discipline. We were just talking about concept, and we were just talking about these parameters that I talk about. These are just a few. We're not even talking about creative research yet. A few factors that influence architectural form. Slowly approaching the end of this exercise, and you will see later on that they are going to start their final term project, and I hope you stay with us and watch the entire process. And again, thank you for watching, and I hope to see you next time.
So that was architect Jim Cameron, who is my esteemed colleague from the architecture program of De La Salle College St. Benilde. So he heads the creative design track, design 1 to 4 of the curriculum for architecture. And what he's just showed us are some of the examples done by students. So this is a glimpse of what the design courses are going to be. So you may ask, why are they doing these sort of things? And they're kind of different from the normal types of architecture that you are used to seeing, especially in the built environment, which is rare. So the job of an architect is not really just for us to just create whatever the client would want. Like, say, if they ask you to create a house and the default design is going to be something with a roof, and normally that's all they want. Normally that's what they're thinking. And some of the old school architects would be doing that very same thing. They will just tend to sometimes even take a look at magazines of European or American or Western types of architecture, and they try to inject it into the built environment here in the Philippines. What ends up happening is it's a copy paste sort of design practice in some of the offices or some of the designers that we have. And sometimes what happens is they just copy and not become so critical in why certain things are implemented into the design. So the job of an architect really nowadays in this time around is to explore and to see new ways of creating forms and at the same time become a logical livable space, a working space, a space that are good, that are in tune with the life of its occupants, the well-being of its occupants, the usefulness of the space, the comfortability, and the considerations of supporting the life of its occupants, the strengths of the occupants, the passions of the occupants. So those are we are trying to educate you with. So our program is in tune with you exploring new things and also at the same time know what is currently and logically being done. And also, of course, the common sense of a very good architecture. So the architecture need not only be aesthetical or sculptural in nature, but also its usefulness, its strength, meaning it should be stable enough to be built. So a good architecture enhances life, enhances the environment, enhances the community. So you can probably see from Jim's analysis of students' exercises, there was a lot of complex forms, and the students were asked to document them in terms of regular architectural methodologies, either with plans, sections, and even isometric views. And sometimes you could even see them illustrating in perspective. So what I'm showing you right now is an example of a form of architecture. So not as complex as what Jim was showing, but rather this is an example of a design, a cube design that is carved out. So this is an example of borrowing from David Umamoto's sculptural objects, which I could probably show here. Some of the so see his work is really David is into the artistic side of architecture, which is these models that he makes. And this is an example of something I made for the drafting class, and it was to show that you can translate his sculptures into architecture, just like what Jim has described in terms of with his students. So there'll be voids and solids and folds and openings of architecture. So in this case, we use the parameters of David Umamoto's openings, solids, and all the exactly as David Umamoto's sculpture shows. So here I translate into an architecture, an example of this. So I made a 3D model of this before. So it's I'm sorry, but since the material was limited to only a clear acrylic at that time, so had to do with this. But I could show you the image where I got it from. So I've deciphered it from David Umamoto's sculpture. And this is a division of, I assume the divisions of this by 9 by 9. So each numerical value is roughly about 1 meter. So I translated it into the architecture in terms of plans. For example, the first level here, the structure was lifted off the ground, and therefore I made use of that and turned it into the staircase or the stair volume. And the surrounding spaces underneath the structure is for the parking space and some covered usable spaces, which probably will be in the lanai. And if we go up first to the second floor, which is the second level of this, is the livable space. So it's fairly limited in terms of the 9 by 9 meters that is provided. So here you could see the layout. This kitchen is pretty small, and I had to work with this because the limitations. Of course, kitchens should be a bit bigger than what this should show. But given this is a very challenging limitation of the dimensions, I had to come up with something viable as fast as I could. So this is just one iteration of what it's supposed to be many iterations. So the first iterations usually aren't the best, but it can be refined later on if you give it more time. So it's just an example of what I wanted to show to students. Here you could see sliding doors. So we're going to be implementing the schematics for a sculpture from one of David Umamoto's sculptures. So I'm not going to be giving this exact sculpture per se. So I am going to reverse the solids and the voids instead. So what ends up becoming is that you will be given the negative version of this, meaning instead of this, which is this architecture, since it's already been given, so I'm going to give it out as an example. You shall be doing the opposite of it. So the voids and I'll show you a closer look at this. So I'll be providing also the 3D version, okay, the 3D file of this model, exact model, so that you could analyze it in CAD to know the dimensions. So you would have an exact carving from the 9 by 9 by 9 meter cube. So when you will be using the voids, for example, the openings of the voids as the openings or the windows for views, and then the solid will be representatives of, say, the walls. The interior walls will be up to you, the segmenting, depending on what design solutions you can come up with. So this is another example of one of his sculptures, which I translated into architecture. So again, I first did what the floor plan. Of course, I sketched it out first in schematic mode and what exactly I was going to do, and then fleshed out all the architectural edifices or architectural solution. So I came up with 3 floors for this type of sculpture. So the sculpture in question is this. So you can't see it, but I will provide you. The light is too strong, but I will be providing you a model of this. Okay, I'm going to show you probably the image of what this sculpture is, but this is mainly the exact replica of this, but this particular cube is 10 by 10 by 10 meters, and therefore I translated it into architectural floor plans, elevation, and section. So you can see the thicknesses of the walls even in the floors here in the section. I will be providing you a link on how to formulate staircases or stair volumes. So you need to watch that video and have a look and how things are, the standards of staircases. Further questions, you would probably ask your professors or your mentors. Here, this is an example of an elevation. So it's basically the section being integrated into the elevation with what's being behind the walls, being illustrated as hidden lines. And then this is the isometric. So you'll be asked also later on to create the isometric. And then, of course, the exploded isometric of this. So the exploded isometric cannot be done unless you finish first the floor plans and sections. So I show these things in a three-dimensional. Okay, so I sketched this over with the iPad Pro in isometric. And of course, these are scale drawings. But for you, you will be using manual drafting equipment. Then I also showed the top or the roof layout. You can see the arrows of the roofs are angled down. And so this is the whole thing. But I would like to show you the animated version of this, or the video time lapse. So I'm just going to play it. So of course I did the floor plans first. I'm gonna fast forward this with the layout. You could see I was making some decisions in erasing some of the parts and then eventually solidifying what I wanted. Of course, indicating also where the section lines were. And I developed the elevations. And then section was a projection of all the floor plans together. And then isometric drawing of this based on measurements from the sculpture of David Umamoto's. Of course, putting in the line values. And then eventually I took like another layer and started constructing the insides. So fast forward. In terms of the real thing or the actual thing that you're going to be doing in the manual is that you will be using tracing paper or Hopia paper to go over this, and you try to do it by layer, meaning per sheet, per floor is per sheet. So I made a color coding here. So think of these levels of isometric as paper over in top of each other. So when I finish these things, so I'm going to fast forward this. I separated each section into these. I laid that out. Okay. So we're still modifying it, correcting it, as you can see. Then after which, this is how I derived the roofing. Then I jumped over to the, you can see here, the top view. Eventually. But the very first things that you need to establish are the floor plans. So again, I'm not going to be giving you this exact model because it's already been solved by students previously. What I'm going to be giving you are the inverted versions, or the opposite, where the voids become solid, and the solids become void. So it's inverted instead. So, but I'm going to give you also this example just for you to have a reference. So it would be very interesting to have a look at what you can come up with these. So again, going back to the first example of David Umamoto's sculpture. So you could see the entire thing here, a whole isometric, whereby I formulated the openings or the voids and placing in windows. For example, these square windows here. And then I use also the voids as openings for windows. It's exactly a translation of a sculpture and then turning into architectural drawings. So you could see the exploded version. So this is not done with the iPad Pro, but I did this manually as an example. That and then the scale of drawing was 1:100. So it's going to be slightly, of course, smaller than the 1:50, which is half the size. And this fit like an A4. So I was working with an A4 type of paper, but you will be working with an A3 paper. And of course, one important aspect of this is also, of course, do buy tracing paper or Hopia paper. Hopia paper is the not so translucent type, and it's a bit cheaper than tracing. So this is the cube, or maybe probably another version of this that you will be provided with. So you can see this is the modeled. So this is the 3D model version of David Umamoto's sculpture, but this is the inverse version of that sculpture. Okay, so if we take a look at this, I've also provided where the sides are. So this is the front, which means this is the main entrance. So this is going to be a translation of this sculpture into a residential. So if we're thinking about that, the front is usually where the road is facing. And of course, we have where the rear is also. So you will be providing the schematic version, a scaled sketch version layout for the floor levels. So you could go up to probably 3 levels, or some of you would like to have 2 levels only, depending on the requirements of what the architectural programming that you want. So you will imagine this as your own house. So you will be providing regular stuff like living room, dining area, bedroom, of course, probably balcony. Parking space could be on the side of the structure, since we do not have any sort of space that a car can fit through. Okay, so it's really up to you to decipher this and translate it into such. So of course, we are expecting everyone to have their own unique layout. It is most probable that none of you will have very similar solutions to this. So you have a free hand in terms of what the layout of the interior walls are going to be and the spaces. So from our previous lessons before, of course, you apply them, like first knowing what the activities that you want, and then you move on to the furniture that are connected to the activities, and then of course the lessons that you've already learned from what the ceiling heights are, the levels that you want, and how big the spaces are supposed to be. Of course, do also consider natural ventilation, where windows are needed. Then again, let me emphasize that, we see voids and solids. You can translate these solids like hollowed walls. So these would be the walls, most probably the outline of the exterior wall. And then the voids could become windows. And this can become like an opening of sorts, like a balcony or a lanai. And this could be a window also. So it really depends on how you translate this. How are you going to use this model? Okay, so this is in 3D. Usually it's in plan, right? When I press on to the view cube, which you do not see here because it's there. This is round thing that you would see. And if we go to isometric, okay, so if we go to, like, say, the view, you would find this view cube. So a round thing would appear somewhere roughly about here when I'm pointing on the upper right hand corner. So there would be also, you can manipulate these things into two viewports if you want to take a look, say, two views. So here you could translate this into an isometric. Okay, so if you want to take a look at the isometric version, is you go and hover and to this corner of this square, and it rotates it. So you can even rotate the views going like this by dragging this entire sort of like perimeter circle to orbit around, to pivot and orbit around. So you can see this, you can zoom in and zoom out. And of course, if you don't need two views, you can always go back to your viewport and make it into a single port, like so. And then if you need to measure something like the dimensions of this, all you have to do is use the command. If you need to measure something, okay, so you go back to your home ribbon and you can find this ruler icon. You see this ruler icon, you press it once and you go for distance as a choice, and you can measure this. Okay, so now you know that this is 10 meters. You can see this. The information can also be displayed here on your command prompt. You do need to extend this to multiple lines. Okay, to multiple lines like that. Usually it's like this. You only see one line, but we need to always expand this to such. Now, again, you can measure distances like the X and the Y, and then you can measure, of course, the height, which is another 10 meters. This is carved out of a 10 meter by 10 meter by 10 meter. So you don't need to dimension this, but rather you can always spot measure all of these and put it on paper. So like this one, what's the distance between this one and to that? Now you can shift right click to snap on to certain things like perpendicular, for example. So that gives you the Z. So you can always look at this with your Z, with your command prompt. The information is there. Z equals to 2 meters or negative 2 meters and such. Now some of you would be asking also, what floor levels would you want these to be? Now, of course, do consider that there's going to be a floor slab and then the ceiling underneath if you're doing the second floor. And therefore, the clearances of any ceiling would actually be minimum 2.1. But that's not ideal. Ideally, a good ceiling would be roughly about 2.4. Standard is 2.7. So do consider all of those. Now, if you take a look at here, what is the distance between this line to the bottom line? It would be 3 meters. If you're not sure, measure again. You get the distance. Now normally there would be perpendicular here, but if you could just spot, from this corner to this corner, and then you extract the information here on the command prompt, then you could see that it's 3 meters above. So minimum wise, that's how you know that this has clearance for anyone who's underneath. But then there's a level here. Now you could translate these solids as really, you can translate them to walls. Now, what do I mean by that? When you are in the outside, on the exterior, you would not notice that this entire thing is going to be solid. So an exterior wall can probably be here, and then these openings, again, as I suggested, this could be open or windowed. This is where you can place your windows if that is the decision. So entrances, for example, here could be this one, it could be open air as a translation, and then an entrance somewhere there. Now, again, they do take note that the heights of doors, the standards that you've already learned from previous exercises, should be applied. So we want to see those standards in. So the newest thing that you could probably be learning from this week is how to place and create stair volumes, which in case I will be providing you with a supplementary video of how videos actually in formulating those that the correct methods. Now, also, if you take a look at here, okay, so the big question really is where is my second floor? Again, as I stated, this is the 3rd meter here on the z-axis or measurement. So what you need to do is to consider like a 500 millimeter type of consideration. So the floor level would be, the second floor would be something like 3.5 meters from the ground or this 0 reference of the model. And then that's where you will be creating the second level. Okay. So if there's enough headroom space for the next one, the 3rd level, if it's possible, you may want to consider that. Probably another consideration you would like to do is that the 3rd level would be not the whole entire floor area. So if these first 2 levels would be full, meaning you want to make use of the outline of the exterior wall, and then the 3rd floor rather, would be just this volume and everything else is open. So of course, do consider that, if this thing is an interior space, they should be protected from the elements. Like, how would you solve? Most probably, this is going to be made of glass, and then operable windows where people can reach them, because we live in the tropics. And then this could be another opportunity for windows and probably openings that the users can you can actually operate. So how do you want to kind of look inside? Okay, so you want to look inside, but you can't. But here's another tip that you could probably want to do if you want to analyze certain things in certain areas. Like, you could slice the object. So this is entirely solid or solid type of object. So this is something that I teach in ARVCOM 3, which is perspective drawing. which is really part of that course is 3D operating CAD in 3D. So in order for you to slice this, you could invoke the command slice. SL is the shortcut. So SL, enter once. You choose the object first, click that, and then press enter if that's the only object that you want to pick. And then you're given all these choices. Okay, the command prompt is here, and then you choose XY. XY. Now it's asking for which plane. So it's cutting from the horizontal plane because that's the XY. So what we're going to do here is first shift right click from ground zero, you want to cut to the level of 3.5. So I click once and then at sign must be there without any spaces. You type in 3.5. No, actually it's not that. Okay, so it has the Z. The first two, which is the X and the Y, is 0, comma, 0. That's the X and the Y. And then followed by a third numerical value, which is comma 3.5. And then enter once. And then it's asking again if you want to keep both objects. And I'm going to say yes for this time, or press enter once. So both. And it's going to cut through the solid. And then you can lift this up and you can move it up. Okay, I'm going to choose the upper part, enter once, and I'm going to click anywhere, or probably I need a pick point somewhere there. Then I can lift it up and you can see the outline of where that level of 3.5 is going to cut. Now you can go and, of course, take a look at the underneath and whatnot. And you can see the outline of the flooring. So this would probably be the outline of your flooring. So it's up to you to utilize whatever space. And then what about this one, this void? It's up to you again to translate into what you need or you can do with it, right? But most importantly is that the exterior should 90% be the same exterior wise. So you keep in mind that there's limitations to what you need to modify. So there's no modifications, for example, of this plane here. You cannot push or subtract it. So all these subtractions that are already incurred, and then the solids, of course, still will remain. So this 90% as much as possible. And then if you are going for a third level, for example, and then that would entice another, say, okay, you inspect where these areas are. It's going to be somewhere here. So that's another 3.5. Also, again, do considerations of your ceiling heights that you need. Okay, you could probably even be going lower than what. No, actually, this is correct already, in essence. But here, that's probably, if you wanted to know some distances again, like I need the distance between here and there. And then I see that it's only 2.5 meters. So the next one would be 3.5, would be this line, that level. And of course, we're going to create also the roof volume, but you can actually make a bit of a thing that you had to have gable roof here, but it could not be seen under when you are on the ground floor. So Therefore, the sacredness of the form still remains the same, at unless you're looking at it from above. So my example also showcases that solution where the volume or the form still remains seen as the sculptural model that it derived from, but it has practical roofings on the inside. So you could use that as an example when solving this. You may want to make another copy when you slice this instead of slicing that main model. But anyway, thing is, let's say I need to slice the third level if I wanted to. So my third level is going to be in this line. So again, slice SL, enter once, click the object, and then when you finish selecting what the object that you want to slice, enter once, type in XY, or you click onto this, and then which point that you want, because I know this for a fact that from here to there, it's 3.5, so therefore I'm just going to choose this corner, and I'm going to keep both sides, enter. So it cuts the solid into that, and then I can lift this up or move it up, and then I can see the outline of the flooring of the insides. So again, you could see probably translate these things as exterior walls. Of course, these sort of corners like a 1 meter by 1 meter, of course, and then it goes in. You go in and you have a 0.2 or 8-inch thickness of walls, and then you have this very strange corner or space. You may need to sort of like find ways or make it as a useful area in designing these spaces of the floor plans. So again, you can see, you can analyze this, you can have this model. So normally I showed the model in class when we had face-to-face sessions, and not like this, because I don't give out the 3D version of this. Since we are all in isolation and at home and during this pandemic, I've decided to release this to you as a reference and for you to operate with. No, so make sure that you are operating with the correct sides, and for you to translate this into the correct orientation. So this is the front. This is the main entrance is going to be, and then of course this is going to be, if this is going to be your third level. All right, let me just measure how many meters left here, if it's realistic enough. Distance, that's 2 meters. So a person can stand here still, but the minimum is roughly about 2.1 for anything that is realistic. But hey, you may tend to modify certain things so that the exterior still remains the same true to the form, but yet here cannot be seen. So there's a way for you to kind of modify certain things and still get away with being true with the form. So maybe that's it. This is how you could probably analyze this model, and you can even slice it vertically if you need to, just to see what's going to happen, and then certain measurements to translate this into architectural floor plans, elevations, and of course sections and isometric eventually. But the first exercise is going to be making schematic floor layout based on the activities you would like to derive from. So the programming is the key in translating this into a realistic type of architecture and understanding spaces that you want to create. So anyway, that ends this video introduction to this new series. So this is going to be from week 8 up to week 13. So the first few, of course, every week we give out iterations of we're going to be giving out, of course, assignments of the requirements in order for us to finish this entire set. So it's not an overwhelming thing that you have to do everything all at once. So it's going to be a guided type of translation to architectural drawings. And of course, proper drafting and lettering should be always be followed. And so see you again next time.